Hey guys, back for another video. Today we've got a Sundown audio amplifier. This is model number SAE 1000D. It's a monoblock class D amplifier. This is a half bridge. I think they were released quite a bit ago. I want to say well over 10 years ago. So very early in line for Sundown. When they released their line of amplifiers. And as you may be aware, most of the amplifiers that Sundown's made up until recently really have been clones of other either Korean or Chinese amplifiers that they're able to place their name on there. So not to take away from it, but they specialize in really the design and engineering of subwoofers, and then everything else is pretty much secondary, whether it's their components, amplifiers. I think they might have just released some other devices, marine devices, etc. So their bread and butter is a subwoofer. That's where their R&D is funded and everything else like that. As far as the remaining lines, they just leverage what everybody else does, right? It's not rocket science. So in this particular case, this amplifier does not turn on at all. No communication once you apply the power remote and ground. No protect, no red light, green light, no any form of communication once it's applied. And so what that makes me think is the fact that it probably is a mechanical failure or something is completely blown to pieces inside where it blew the traces away and you don't even have enough power to enable the self-check circuitry, which is usually temperature, over voltage, or over current. So let's take a shot at this. Let's see what we can find out and hopefully diagnose it. I've got my handy little fluke multimeter here. I've got it on looking at resistance. And so the first thing I want to do is just kind of look at any shorts between the input power, right? So we're looking at the 12 volt main power line, plus we have ground as well as the remote. And so I just want to make sure there's no, maybe I can put this, that would help. There we go. No short, so it looks like it is just charging some capacitors in here. There we go, we got a reflection. Yep, so no shorts. Well, it's a pretty high impedance in between. Let's look at between the remote. 12 volt. And open. That's good, no short. And then we can also look at between remote and ground. So again, no shorts, which is good. So as far as input power being shorted, I don't see that. Again, the FETs could have broken open, which means there is no short. The next thing I want to do is look at the fuses. This has 3 40 amp fuses. So rule of thumb is you take the total sum of the current rating of these fuses and you multiply by 10. And that's usually how many RMS watts the amp can actually do. This varies from manufacturer to manufacturer, whether it's one of the more reputable ones or some of the generic ones that not always accurate, but it's a good rule of thumb. So in this particular case, 40 times 3, it's going to be 120. 120 times 10, that's going to give you approximately 1200 watts RMS, and this thing probably does it easily. So let's check the fuses just to make sure none of the fuses are blown. Obviously, if any of them are blown, we would not have power. So that's 0.4, that's a short, which means fuse is still intact. That's 0.4, that's good. Is that open? Well, I think this looks like it's open. Let's pull it out and confirm. Hopefully that's it. I doubt it, but that'd be too easy, wouldn't it? Let's see here. It's a short. So this is a fuse that is okay. I'm going to put it back in there and measure it again just like I measured the other two. I wasn't making a good contact. There's our short. So it's not the fuses, not the input rails. The output rails, even if they're open or short, shouldn't impact, any communication as far as the self-check circuitry, either being in protect mode or not. So I don't see any shorts there. This should be, let's see, what do we have? Minus, plus, minus, plus. The minuses should actually be tied together at the input. Not sure if I got a good connection there. It looks like a little oxidized. Short between the negatives, and let's try the positives. Short, so that's right. Positive to negative. Okay. Positive to negative. Okay, so not seeing any thing that stands out here, so I guess the next step is to open it up and see what we can find. So let's rock and roll. Okay, so I see 6 screws that hold the bottom plate in. Let's go ahead and take a shot at those and see if we can find anything that jumps at us. Hoping to see some carbon deposit in there, which just tells me we've got a broken trace or some busted FETs, and usually it would be all of them if it wasn't open. And we have no shorts at the input, so I don't know, doesn't seem, didn't smell or anything like that, so let's just see what we can find. All right. Okay. All right, so famous pry tool. Use it for everything. There we go. All right, let's take a look in here. What do we see? Just making my way around. So what I usually like to do is just to be consistent, is start in little tiny sections, work my way up and down, up and down. It's very easy for us just to kind of be attracted to the bigger devices. So let me look left-hand side, making my way to the right-hand side. Hopefully you guys can see okay in here. And I don't see anything that jumps out at me. Man, board looks really in good shape. So, okay. Well, we have it open. Let's do some measurements. Can't go wrong with having a good old multimeter. What we'll do is look at the power supply stage and then look at our output stage. So on this particular amp, again, this is a half bridge topology, kind of standard. I don't know what they call, I guess Korean style, right? It's not really Korean style. It just has become a very popular term because of the manufacturing. They do tend to have a lot of the Korean amplifiers being half-bridge amplifiers, but the same design is replicated in China, overseas. Even the Brazilian ones, which tend to have more of a reputation of being the full bridge, which is surprisingly a little bit more efficient for the size, so watts per size, and also reflected in the pricing. They tend to be more cost effective, but this is most likely made in China, as it says right here. So nothing special about this. All right, so let's put our multimeter on reading our resistance. What we're gonna do is look at the power supply stage, and then we'll come back and look at the output stage here. So hopefully you guys can see my multimeter. Let's move it right over here. And what I'm looking for is to see if there's any shorts. So no shorts here. It's 320 ohms, 320 ohms. And I'm looking source to drain on each of the MOSFETs. 317, 317, 317, 18 is close enough, 318. Okay, so I don't see anything there. Here at the very end, we have our rectifiers. These take the DC input voltage and rectify it. So let's see if we have any issues with our rectifiers. Usually it's center tapped, so let's see here. Yep, no issues. Same center point, go to the other leg. No issues. Go to the other one. No issues. Okay, so input power FETs are fine. Input rectifiers are fine. Let's switch it up to this side. At least nothing noticeable thus far. The output stage. Source to drain. 100K. 100K. 100K, 99K, close enough for government work. 99K, 99K. Okay. No issues with the FETs. That would make sense. They're not shorted, and that's good. I don't see any carbon deposits. I don't see residue where it might have been overheated. Toroid transformer are not loose. I don't see any bulging capacitors. So that's good. I've got that relay. If you watched my video on the Kicker ZX repair, this had gone bad. But in this particular case, a bad relay wouldn't prevent any of the protection circuitry or notification as far as either it's powered on or in protect mode to be activated. So I guess the next step is what I will do is go ahead and remove this entire board from the chassis. I want to look at the bottom side and then if nothing is noticeable there, I'll go ahead and start troubleshooting the various drive ICs and protection ICs. So, which is always not fun because everybody tends to use different things. And I'm just now noticing that, I'm gonna zoom in on here. Pretty sure that's scratched off. So I'm not sure if you can see that here, but it looks like this IC, which may be this primary drive circuit or IC, chip, had the part number scratched off. And it doesn't surprise me. I've seen this before. In fact, some of the SFB amplifiers that I've repaired, Sundown has actually removed all of the silk screening from the chips and replaced them with either a letter or a number. That way, when people look at it, they're not able to, first of all, copy their design, and B, make the repairs, which I think is just stupid, but that's just my opinion. Who cares, right? So here I see that they scratched it off. I'm not sure if I see any of the others. I can kind of see the silk screening on some of the other big ICs. There's the FETs. It'll be interesting to see the FETs. I would guess that if they're consistent, that they probably removed all the part numbers from their FETs as well. So, all right, let's come back as I disassemble the board. It looks like that's going to be pretty straightforward. I've got some Allen key type screws here. I'll remove the end caps. I've got them here on this side. I'll remove the end caps here. And then let me see if I see screws holding this down. It looks like there's really no screws holding the board down to the chassis other than what is holding the FETs down. So it should be straightforward. Let me go ahead and start on it and we'll get back to it. All right, guys, so I was able to remove all the heat sinks that secure the various MOSFETs, rectifiers. Oh, forgot one here. This is a temperature sensor. So not really a heat sink, it's just a screw. Don't want to strip it, so I want to make sure a lot of weight on it, or have the right head side. There we go. Last thing we want to do is strip one of these screws and leave a part on there if you really have to take the board apart. So, okay, so that is the screw for the thermistor or temperature sensor on here that looks at the temperature rise of the heatsink. If it gets over a certain temperature, it will go into protect mode. So let me just slide that out. Okay, got all the heat sinks pulled away, and then I went here and removed all the Allen screws that were holding it to the heatsink. This is a 2.5 millimeter that I had to use on these. I didn't unscrew the area that holds the controls to the board, as you can just basically lift it up once it's loosened up. So you do want to be careful not to stress the board, as you can actually break traces when pulling this apart. So I'm gonna try to do it carefully here and just gently loosen up the various FETs and diodes. Oh, I do see one screw here, so that's good. I'm glad they actually put that there, because I was questioning why there wasn't a screw holding it in place. So there's one, and I'm gonna check to make sure there's no others before I put a lot of stress or pressure on here. So get this out of there. I have a trusty little bag of all my screws. Oh, excuse me. So I don't lose anything. And I put back whatever I take out. So looks like that probably took care of it. Okay, I would say there's something in here, and there sure is, right by the caps. So that's good. Further support. Get this out. There we go, come on. Well, one thing I learned is you never want to force anything. So even as I was taking the board out, and something as simple as this screw, just take your time. Worst case is you can put everything back and leave it as is. So don't want to break anything, because then you just have more work to do. So it looks like we loosened up everything here, loosened up everything here. Should be able to, for the most part, slide this out, and there we go. All right, so let's take a look at the back here. Let's see what we have. It's a lot prettier on the front, huh? All right. So just taking a look, again, what I am looking for is any carbon deposits where it could have blown up, broken traces. Here I see some residue of moisture. I'm not sure if that's remnant flux or actual deposits of like moisture over time. Again, if something was shorted, it should have gone in protect mode. So what I will do here, since I don't see anything that stands out like a sore thumb at the moment, is I'm gonna clean this off with isopropyl and a brush, and then kind of do my continuity tests again. I do see something over here. Looks like more residue and dirt, but that's the next step. Is I'll get some isopropyl, alcohol, and then just clean off the back. Most likely this is flux residue here. What I will try not to do is get it on the back of the FET, so to maintain the same thermal goop or thermal adhesive that bonds to the heatsink, and just redo my measurements again. So let's see what that looks like. All right, so I was able to get the board out, and as discussed earlier, I was able to look at the back. Nothing stood out at all. It looked like it was just really just a buildup of flux residue, which is the aftermath of using this much solder, whether it's a reflow or by hand. So got that cleaned up, and the following thing I did was to do some continuity check. Again, the fundamental problem with this amplifier is even after applying power, there's no response or feedback at all from the amplifier. Usually if it was a short or power issues or anything else, it would power on and go directly into protect mode. You also have the indicator to show that you have power applied. We're not seeing any of that. So as I started troubleshooting, what I did here, and I'm gonna just take my camera and move it over to the left a little bit, to look at the continuity between the ground and the source of all of the FETs. And it's good contact, right? So you can see on my multimeter here, let me get it in a better view. There we go. Here's my ground, and here's my source of each of the FETs. And that is pretty consistent, so it needs to be that. And I made my way around all of those. I did the same thing for the power. This is the 12 volt to see kind of the primary into this large coil. And let me make sure, there we go. We have consistent connections to it. What I struggled to find was connectivity from the remote to the rest of the board. And so what I did to troubleshoot it, I couldn't find visible traces from the 2-layer board. It does look like a 2-layer board on here. And so I flipped it over. And here I have the remote wire. And I was trying to find the circuitry that leads from the remote wire to the main small signal input. So this enables the amp to turn on, turn off. And I did find that there is a point right here, and I will put it on an audible mode so you can hear that it does have continuity to a surface mount resistor, and that resistor is marked 512. And what that is, usually the last number or the last two will determine how many zeros there are. So 512 says that there's 2 zeros after the 51, which tells you it's a 5.1 kilo ohm resistor. When I go to the other side of that resistor, you can see it's still open. There's no resistors measurement whatsoever. And when I remove it from where the remote wire is and measure right across that resistor, again, it's open. So what that tells me is that resistor is bad. And if that resistor is bad and it's open, it's like a fuse that is open, and it will not allow the 12 volt remote signal to make it through the small signal circuitry that enables the amplifier to turn on, start the switching for the power supply and the output stage. So what I am going to do now is go ahead and replace that resistor. And again, I will show, you should be able to measure across any resistance, even if it's got a whole bunch of parallel circuitry around it, some resistance value, but you can see that there is open. It's an open circuit in between, but yet from one end to the resistor, you have continuity there, and it just doesn't go anywhere after that resistor. So that would make sense. That's why if there's no remote signal, the amplifier will not turn on. So what I'm going to do is I'm going to go ahead and remove this. It looks like a it's not a 1206, maybe a 0803. I think that's right. A smaller surface mount resistor, and find something that is comparable. I believe I've got these 5Ks around, and replace it and see if I get continuity. And if I do, I'm going to go ahead and try to power it on and see if I can get any of the feedback response as far as the LED visuals and the self checks. All right. Okay, so I think this did it. Was able to replace the old resistor 0805 package that was 5.1 kilo ohms, which is 5,100 ohms. Replaced it, swapped it out with a new one. Went ahead and put it on the test bench since I was there in my solder station, and we've got power. And so I guess the next thing now is to go ahead and put it together and make sure I actually run it through what I would traditionally do with any other amplifier. Just high power, let it consistently run for a while, heat up to make sure nothing is off and nothing else is wrong with it. But that is huge. We weren't getting any feedback before as far as power, and when I actually applied power, I heard this relay kick on immediately. So that is good news. So now I'm gonna start assembling it and testing it. Well, here it is, completed product. Able to go ahead and replace the resistor that was kind of at the input of the remote wire. Not sure how it failed, since it was a pretty small size 0805, 0603 type surface mount, probably just over time, understanding the age of this amplifier. So replacing that seems to fix the issue I was having, which was the fact it wasn't powering up before. So I've got it connected to my benchtop power supply here, and just a simple low current connection to make sure that it does power on. So once I turn this up, you'll see that immediately jumps on. You heard the little relay in there, and boom, there we go. We've got the green power light on. And just as important is the fact that we don't have that red line on for protect. So again, usually with these amplifiers, half bridge, full bridge, whatever, class A, B, class D, the protection circuitry is pretty consistent. Thermal protection, over voltage, over current. Some go above and beyond by doing under voltage, right? If it's too low voltage, it'll shut off. Same thing for also sometimes under current. I don't really see it in car audio. So that being said, it works. I got it connected to my little test subwoofer. This is just a simple Hertz 10-inch. Sounds great. Good sound quality. So let's go ahead and unpause this. And you can see current draw changes as music plays. Still got power. I've also got our bass remote volume connected to make sure that works just fine. So let me see if you guys can tell the difference over video here. So no output, pretty consistent. And when I change all this to the right, you'll see various current draw. Down. Nothing. KCYY San Antonio Y100. There you go. Texas Military City. It works, guys. San Antonio's new country leader. Y100. Let's pause that. So again, simple repair in this sense. We get lucky with some of these amplifiers. But it looks like it's working. But as usual, what I'm going to do is probably put a certain frequency tone on there on the subwoofer. Let it run, whether it's anywhere from 20 to 50 hertz. Just let it run there for a while, see if it gets warm. Right now, I don't feel anything, just sitting by. Make sure it do his due diligence so nothing else fails. But again, another successful repair. This is for the Sundown SAE 1000D, 1000 RMS at 1 ohm. Amplifier, half bridge amplifier, and pleased that it was a pretty easy and simple repair. So I think the thing I like about this amplifier, again, ease of disassembly and reassembly, and its simplicity, right? It's not any different than any of the other amplifiers out there, but obviously the Sundown audio has been able to market to a select genre of folks that are willing to pay the price for the name, but it's not any different than what you're getting out from the rest of that industry out there for these half bridge 1000 watt type amplifiers. So Thanks for watching. If you enjoy, please subscribe, like, all that fun stuff. And again, to be consistent, I'm going to try to find videos and make content on things that don't exist out there, right? I didn't see a lot of videos on this type of Sundown audio amplifier. So hopefully it helps somebody out there to troubleshoot it. Just look at the basics, check out the input, check out the output, check out the FETs, rectifiers, right? Do a visual inspection, make sure that you don't have any carbon deposits or smoke, to make sure nothing's blown off, make sure the traces are intact, solder joints are good, clean off the board if you can. Often when we put these in vehicles, we put them under car seats, we put them in a trunk, they're exposed to a lot of humidity, moisture. Had someone just recently post on one of the forums, he went to the lake all day long and his amp stopped working. Well, when he took it apart, he found out that it was just full of, what did he say, Mike's Hard Lemonade or Twisted Tea, whatever it was. So sometimes these amps just, need some TLC and to clean them up, and they should be good to go. Thank you for watching. See you next time.